Why are axes important for NumPy array indexing? Imagine trying to find your way through a maze without knowing the directions. That's what working with multidimensional arrays feels like without understanding axes. Axes are the lines that define the structure of your data in NumPy arrays. They tell you which way the data extends and how to access specific parts of it. When you work with one-dimensional arrays, it's simple because there is only one axis. But as soon as you add more dimensions, like in two-dimensional or three-dimensional arrays, knowing which axis is which becomes essential. For example, in a two-dimensional array, the first axis is usually called the row axis, and the second is the column axis. If you want to access a specific element, you need to specify an index for each axis. So, if you write array 2, 3, you are asking for the element in the third row and the fourth column. Without understanding axes, it's easy to get confused about what each index refers to. Slicing arrays is another area where axes matter a lot. If you want to get a subset of data, you need to tell NumPy which part along each axis you want. For instance, slicing rows from 0 to 3 and columns from 5 to 10 involves understanding which axis is which. This control allows you to extract just the data you need for analysis or visualization. Axes also help organize complex data like images or videos. In a three-dimensional array representing a color image, one axis might be the height, another the width, and the third the color channels. Knowing which axis is which helps you access specific pixels or color information efficiently. Misunderstanding axes can lead to errors, like trying to access data outside the bounds of an array. For example, if you try to access an index that doesn't exist along a certain axis, NumPy will give you an index error. Knowing the size of each axis prevents these mistakes. Advanced operations like broadcasting or applying functions along specific dimensions also depend on axes. They help align data correctly so calculations work as expected. When you write 3, you are directly linking the indices to the axes, making your code precise and predictable. In short, axes are the backbone of understanding how data is organized in NumPy arrays. They define the shape and direction of your data, guiding how you access, slice, and manipulate it. Mastering axes makes working with multidimensional data much clearer and more efficient.